Geotrig, this is lesson 2, day 3. So we have a couple examples and a couple definitions to go through today. Finish up the lesson. This one here, guys, if you remember, volume. What was the definition for volume again? Of most shapes. Length times width times height if it's a rectangular solid. I said let's back up a little bit more from that. What would we use for a very general formula for volume? Area of base times height. So V equals the AOB times height. And so the area of the base times height is the volume. Now, guys, it's very important that when you choose your base, it has to be the base that runs through the whole entire object. As you can see on the screen here, we have an object here. If we could imagine this thing laying on the counter right now, is it laying on its base? I would almost think that the bottom here, right, is the base. Is that consistent all the way through?
No, perhaps.
If I start at the very bottom of this base and work my way up, would it be the exact same photo every single time, every slice? To me, it would not. Because this rounded edge right here, right? Some slices will be a little bit bigger or smaller than another one. And so I have to find where is it consistent that if I cut it, it'll be exactly the same shape. And I think it'd be if I stood it up on this edge right here, right? Do you see that the front face? It's like a loaf of bread, straight back. That is the base. The base has the 2x, the 3x on it, and then half of a circle. Okay, so it's a semicircle attached to a rectangle. And then y then is the height. Notice these are all variables. They're letters. So I cannot tell you, or you guys cannot find a specific volume. It's an abstract volume, which means it's made up. Basically, you're going to create a formula. And then what happens if I told you X and I told you Y, you could plug them in and you have it. So I need to find the volume of that particular shape. And it has 3x, 2x. What is the radius of that circle?
1.
It's x, right? It's x because from all the way across is 2x. Therefore, half of it is x. So, length times width, which would be 2x times 3x. I think everybody would agree with this. What does that end up being?
6x squared.
6x squared. So the area of the rectangle itself is 6x squared. Now we have to find that semicircle or half circle. That's pi r squared over 2, because it's half of a circle. And the radius is x. So it's x squared over 2. That's actually the area right there. Pi x squared over 2. I have rectangle, half of a circle. The total area of that face is 6x squared plus x squared pi over 2. Do you guys agree with that? But that's the area of the base, right? That is this thing. To find the volume, I'm going to take all of that and multiply it by height. And the height is? Why? Because the height is the thing that's going all the way back. It's bringing that face all the way to the back. So volume, V equals the area of the base times the height. Now the question could come up to this. Do I distribute the y in, or do I leave it out? Essentially, is there a difference in its value? There's no difference in the value. So you could leave it, because that way you have your x's on the inside and your y on the outside. Or, if you really feel inclined, it'd be 6x squared y plus x squared y pi all over 2. So there's different ways that you could write this. Means the same thing. And in this case, because they're all variables, I don't think there's a right or a wrong. So the next thing we're going to talk about is surface area, particularly of cones. But maybe before we even talk about just cones themselves, what we're going to do then is talk about surface area. What is surface area?
Area of the surface.
Area of the surface. Okay, area of a surface. But if I had an object, because now you're using surface in a definition of surface area, but what does it mean if I have an object? What does it mean to have the surface area? What is the surface area of a box? Top, the side, bottom, the back, the other side, and the front. It's all sides. So it's the area of every face of the object added up. So the surface, area of the surface, so it's all the areas of all faces, that's really bad writing, added up. All of the faces added up. All the areas that make up the object added up. Now we need to talk about cones or pyramids and the fact that they have a slant height, and the slant height is different than the true height. I'm going to erase this eventually. If I put a cone with a point on top, I could draw a cone. Yes?
Yes.
The height of a cone is the height that goes from the very tippity top, perpendicular to the ground. Right there. Boom. I have a height, and it's perpendicular to the base. That's h. You guys agree? What's the slant height then?
Is it the height of the slanted line?
The height of the slanted line. What do you mean by that? Because you're not necessarily wrong. I think you're saying it right. You're saying it wrong, but you're thinking probably the right place.
I don't know, like,
Because isn't this height right here that we're showing right here the height of the line that's slanted?
no.
No. That's straight down. What do you mean then?
Well, the length of the side,
The length of the actual diagonal maybe, or something, or the side that's on its, that's turning. I don't know how you say it without saying slant, right?
Yeah.
So this, right? This is the slant height. So if this here is the slant height, that is true. Slant height is the side of the pyramid. We actually call that sometimes like an L. Sometimes they use like a lowercase l or a cursive L in a way that kind of like hooks back up a little bit. That is what they denote for the slant height. It's the actual line from the top to the edge of the base. Maybe is that a better definition of slant height? top to the edge of the base. And this doesn't matter, guys, if we're talking about a cone or if we're talking about a pyramid. The edge here, right, from the top to the edge of the, and it doesn't have to be at the corner. It can be to this part right here. Actually, that probably would be the most appropriate place. So if I take that out, so it forms a right angle. It will form a right angle with the ground. Not right angle this way, but it forms a right angle with the actual side. Do you see that? There's a difference. The side itself are slanted. You're not going to have a right angle, but you'll have a right angle to its perpendicular side. That's slant height. So, guys, come up with some way for you guys to remember where that slant height is. So, but now we got some examples. The radius of a base of a right circular cone. Right circular cone, guys, is what you guys would agree to be a cone. As in, it's got a point with a circular base on the bottom, and it goes straight up and down. Okay? The height is the middle. The slant height of the cone is 10. Find the surface area of the cone. So, if it doesn't have a figure for you to look at, then you should draw one. There's my cone. It has a radius of 8. So if I go down here, this is 8. And it says it has a slant height of 10. So 10's on the outside, right? Find the surface area of the cone. There are two different things to this cone. There's a bottom and there's a slanted top. If we're going to paint this object, do I paint the inside? Do I fill it up with paint? No, we're not looking for the volume. We're looking for area. Which means I would paint the bottom of the cone. Yes? The bottom of a cone is a circle with a radius of 8, which is nice because I could figure that out. But the top, if I was to take a pair of scissors, cut the bottom of the cone off, so cut around the cone, and then on the slanted edge, take my scissors and cut all the way up to the top. And I unroll it. Is it going to be a square or a rectangle? No. I'm going to pause the video. I'm going to get a piece of paper and show you that. So, it doesn't form a rectangle, but if we took and cut the sides, I think you guys could see that it's still got a triangle on the bottom, but it ends up being this shape. It's like a piece of pie. Wait a minute, piece of pie. We have another name for that piece of pie mathematically.
Pizza.
Starts with an S.
Circle.
It ends in a
Circular.
Sector. It's a sector. So it's a sector. And so this is a sector. And the cool thing is that this edge is the length of that edge, which is the what of the circle?
Circumference.
Circumference.
Oh yeah, I'm a boss.
Interesting. Guess what? The height of this was 10. This is 2 pi r, or 2 pi times 10, or 20 pi. You got 5 minutes, guys. That's the circumference of the bottom. But how does that help us? Do we have any numbers yet when we did sectors, we needed to do what on the top? We needed to know the angle. Okay, guys. So, it seems like we don't have enough information here to actually say that because I can't guarantee what that angle is here. So there's got to be some other way. There's actually a formula for this, guys. That formula for the slant, for the area of the top of the cone is pi RL. Pi RL, that's a lowercase l, where L is the slant height, R is the radius. So in this case, it's pi times 8 times 10, or 80 pi. We also need to know this over here, pi r squared. And so, pi times 8 squared, which is 64 pi. So we got 64 pi for the circle. I'm not sure why it's not on the screen yet, guys. We're lagging a little bit. But it ends up being 64 pi plus 80 pi, which ends up being 144 pi. And this happens to be meters squared. So, homework is day 3, 5, 9, 15, 21, 22, 23, 26, 27, 28. Have a great day. Yes, it's a lot, but we do have a lot of time together in class to get this done.